As we have all heard, digital twin is all about integrating the various aspects of right from engineering, construction, operation and maintenance, doing some real-time check on the progress, as well as making sure that the entire information, the life cycle information of the project is available on one platform. How do we achieve this? In our organization, it of course starts from engineering, where the entire information is integrated. We have a team which is specifically focusing on BIM and bringing the digital twin on platform, and the end users, which are the project sites, the construction teams, the operation and maintenance teams, and of course the client who wants to see the real-time progress of the project. These are some of the digital twins of the assets that we have built right now. As you can see, on the right is the 3D model of the plant, and on the left is the physical asset, which is in today. It looks like this today. We take a little deeper look at section by section. So this is the crushing and screening section. As you can see, we've been monitoring this project all the way through construction through the digital twin in terms of synchronizing it with the Primavera P6 schedule, which helps us to understand where are we in real time versus our plan as we had planned in the baseline schedule. There are other sections of the plant. The whole plant is covered. It becomes extremely easy for the construction team, which is not so close to the digital technology, in understanding the various aspects of the plant and understanding the complexity of construction, delivering them. This is on the utilities. So these kind of plants cover buildings, roads, villages, utilities, process plants. So it's an integrated plant which the digital twin is made for all assets, all types of assets, irrespective of being process or non-process oriented. So this is the virtual representation. So here we see the real-time progress. So how it works is basically we have the 3D model first. We have the BIM integrated with the P6. The construction team actually delivers the asset physically on site. All the construction information, the material information from various sub-suppliers as well as from our construction team is then integrated back into the 3D model, and that's when we create a digital twin. Of course, this is a very basic model. If you look at pumps, if you look at process equipment, all the data then gets into the system. So how do we do that? We first capture the data, we validate it, we integrate it from the various sources that are coming from, we rationalize it because sometimes there's too much of data to process, so we need to pick and choose what's really relevant, and then we visualize it. These are the steps that we normally follow. I have mentioned Aviva here, but that's not the only platform we use. We're pretty much an open source company, so this is just for sake of reference. So how does it help? As I said earlier, we use this all the way from engineering, construction, handing over to the client, and then the client uses it for preventive maintenance, operation and maintenance, etc. The various softwares that we use is Aviva 3D, Autodesk, Bentley. Some of you are here already with your stalls outside. It's not to promote any particular software, but there are a lot of opportunities. We wish that one day we have all these facilities on one single platform for our life to be a little easier. This is on the drawing board. As you can see, the PFDs, P&IDs are drawn, and then as you get into the detail, every component of the project, there's a data sheet which gives the size, dimensions, operating specifications, etc. It's a fairly detailed information which is available, which could be used for replacing the equipment, preventive maintenance, as well as also ensuring this plant is operated with all the safety. There are different levels of hierarchy of information. I'll not get into details. It's just a sample for all of you to understand that you can keep dwelling down into details to understand every single component and get to every single detail in the project. The process goes like this. We have the PFDs, P&IDs, typically in any kind of EPC or industrial process project. Those are then taken into engineering, where is detail engineering, so all the information is then taken on the drawing board. We have a 3D model developed. We integrate that with the schedule, and then we could have a real-time assessment. As you can see here, we've monitored this project over the last 2 years on a plan versus actual and forecast basis with different color combinations, which is very easy and simple to understand for construction team, for progress team, as well as the client's team. Even the commercial colleagues who are not very familiar with technical terminologies are able to understand the progress with a lot of ease. We've used digital twin extensively for doing erection rehearsals. You know, it's always very complicated when you do heavy lifts in excess of 200, 300 tons and by using mega cranes. We've always seen challenges, we've always seen issues coming up during the final assembly. And so what we did here is we built the whole model on a digital platform with the digital rehearsal, making sure that the clashes are checked, making sure the crane movement is properly analyzed, the placement of the crane. So which was earlier done on 2D drawings is now done on 3D platforms. And this gives you a very good control when you actually hit the ground with those large equipment. First and foremost, it gives you complete safety of operations, and second, you don't hit surprises when you are on the ground. There are several such examples. This is a live example of the project that we did. As you can see, this is the silo roof which is being assembled. It's 120 tons being lifted by a 650-ton crane. So the entire digital rehearsal of the installation was done 4 months prior to the actual installation on site, and there were a lot of issues which were sorted out on the digital platform before it was taken on the field. There are more examples. This is a project in Ras Al Khaimah in UAE, and we've erected some large hoppers there inside a silo. This is a project under construction at this point of time. We were able to get into every level of detail, including the lugging and lifting mechanisms. This is a cross-section of the same project. As you can see, the pink color, what you see is the civil silo, and the internal parts are steel. These were all analyzed. Of course, the design did do finite element analysis, but from construction point of view, the digital twin helped a lot in terms of making sure that when we actually placed the hoppers inside the silo, they were fitting in well, and we didn't have any surprises. Formwork is all now. Earlier days, the site construction team used to analyze and do their own formwork designs, but now with the digital twin, you have them all on the drawing table much ahead. You exactly know what material to order, what kind of formworks to create, and this definitely makes the construction more safe on site, and definitely on time, because you don't have to do hit and trials on the construction site. I mentioned about this, when we synchronize the Primavera P6 with the 3D model, you can actually do online monitoring of the project, and this is what we did for the first time on this project, and the client was quite pleased to see the way the whole thing was integrated. And of course, then we have the virtual reality, so we can train our people even before they hit the ground to understand how the project looks like. They can walk through the project. This is exactly what we also do in terms of training and making our people aware of the plant. And of course, when the client visits, they could also have a virtual tour of the plant to understand what they are getting at the end of the project.